6.4. Let me get my colors figured out first. Anyway, sorry, here we go. Section 6.4 is the perfect follow-up to 6.3. And because of what we learned in 6.3, I will not have to reteach a whole lot. There's just a very, very, very easy leap to make here, coming from 6.3 into 6.4. But really quick, a look back on one of the concepts from before. Fill in the blanks with the correct inequality symbol. Each line is describing how the graph would be shaded in. Well, it's not how the graph would be shaded in, and also whether the line would be dotted or dashed, or if the line would be solid. So what symbol for an inequality, you know what I mean? When you graphed it, the line would be dotted and then you would shade below. That would be a strictly less than. Again, this is review from last section. Dotted and above, or dashed and above, would be strictly a greater than. Now solid, now there would be like an or equal to, but we're shading below, so it's less than or equal to. And of course, solid and shading above, solid line shading above that solid line would be a greater, like if you have a greater than or equal to symbol. So that's a look back from last section. Just a quick reminder, in case it's been a good number of days since you looked at 6.3, you know, whether you're absent or, you know, I don't know. So here we go. Graph both inequalities on the coordinate plane. All right, let's just cut to the chase. This, did I mention that this is called systems of linear inequalities? All that really means is we're going to be working with numerous linear inequalities at the same time. Here, just two. So we're going to be working with two inequalities at the same time. And what would be the solutions to the system? You know, what would solve both of them at the same time? Again, it's the same as in the past when we worked with like systems of something. It was like a pair of equations, and now here it's a pair of inequalities, and we want to know what solves both of them. Because I'll tell you right now, this guy has its own, you know, separate solutions. This guy has its own separate solutions. But what solutions do they share in common, if any? So what we're going to do is graph them both on the same plane and see what, like literally see what solutions they have in common. So as always, this is going to be, you know, the graph where the line has a b value of -2 and a slope of 1. Again, I'm not going to reteach stuff over and over again. Oops, little glitch in the matrix. And this is going to be a solid line because of the symbol. The straightest line. And we're going to now shade below. Now, I hope you haven't gotten ahead of me, because you might want to shade very, very lightly. Okay, what the heck? This is the first time I've chosen the eraser instead of the highlighter. So again, shade very lightly, okay, but everywhere. Okay, be thorough about it. shade everywhere very lightly. And now we're just going to graph the other one on the same, let me fix that quick. Now we're going to graph the other one, but on the same plane. And again, mx plus b, our b value here is going to be 0. Our m is -1, so that means down 1, right 1. And I'm looking at the symbol already as I do this, and it's going to be dashed. So make sure you dash your line when you're supposed to. Make it solid when you're supposed to. And this guy is going to be, since it's a greater than, we're going to shade above. And now look, everywhere above that dashed line, okay? And this question here, at what points do they meet? It's basically where, like, you double shaded, you know, so what section of the graph, of the plane, did we shade double? And it looks like, look, looks like over here. So for your final answer, like your final graph, all you really want to do is just kind of like darken that in a little bit, because really and technically this is the only part that should be graphed at the end of the day. You know, that's the overall solution to the system, to the pair of inequalities, okay? And that's all you're going to do. So again, like being able to piggyback off of the last section, 6.3, here's what I always say. I've said this for years, and I'll probably say this for the rest of my career, every year, every time I teach this. If you understood 6.3, then this is a very, 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 very easy leap for you, because if you can graph one of these things at a time, why can't you graph two of them at the same time? And the only plot twist other than that is you just have to make sure that you kind of darken in where you shaded double, because your final see, technically this is not even a part of the final answer, and this isn't either. You know, you could almost like argue that you should erase this or whatever, I don't know, but the only plot twist is that you have to darken in where you shaded double. That's it. So again, if you can graph one of these things, you can graph two of them. Easy peasy, lemon squeezy. So just here's more examples, right? Let's do a few more examples, I guess, just for the heck of it. But it's going to be the same thing over and over again. In this guy, looks like our, I might as well write this all down now. Ooh, B is 2, so is M. But we like slope as a fraction. So that's B, move with M. Might as well make all those other dots. This is going to be what? Solid or dashed? Solid. And we're going to shade below because it's a less than. So here's what some people do. So you might want to adopt this technique of light shading and stuff and just kind of go all in one direction there. Or you can like literally shade, I don't know, whatever you want to do. Over here it looks like our B value is going to be 1. Our M value is what? -1, which means -1 over 1. So B value of 1. M, so down 1, right 1, down 1, right 1, down 1, right 1. Might as well make these dots as well. And this is going to be a dashed line. Right? And as far as the shading goes, this is a greater than. So we shade above. And so here's what you might want to do. We shade above, right? Keep your eye on the dashed line. We're shading above. And so this technique should also make it pretty clear where you shaded double, which is like, all here. And so you might want to just kind of like make sure it's clear where your final graph is. Which is all there. Next example, why not? Nothing new on this one. Our B value is what? -3. Looks like our M value, our slope, is 5. So 5/1 for rise over run. Begin with B, move with M. So that's what? Rise of 1, 2, 3, 4, 5. Oh, you idiot. You rise and you run. Rise over run. God, you lose concentration for a split second. Look what happens. It's just a greater than, so it's going to be a dashed line, and we're going to shade above. Greater than means a dashed line, and we shade above. So first the dashed line, and we shade, which one's above? So we go to above would be here. Shade very lightly, thinking ahead and stuff. You don't want to darken it. You don't know what your final shading is going to be, so you just want to shade very lightly for now. And so here, what's our B value? B value is 1. Our M value is -2, and so -2/1 for rise over run. Begin with B, move with M. That's down 2, right 1. And it's going to be solid, because the less than or equal to, it's going to be solid, and we're going to shade below. Now again, these examples are pretty much all the same. If you want to try them first before I do, whatever, it might be a good idea. So what I say, we're going to shade below. So all the way, man. All below the solid line. And it looks like where we shaded double for my final answer was like all of this, right? So my final shading is here, right? And that would be my final graph. Again, you might want to try this one on your own first, so I'll give you, you can pause the video. I'm going to go in 5, 4, 3, 2, 1. Here I go. Ooh. My M is already a fraction for once in a while here. B equals 1. Yeah, so. Gosh darn it. Begin with B. Begin with B. So move with M. That's -2, +5. That's going to be solid. And because it's or equal to, and it's going to shade. Shading above. Lightly. And the other guy, looks like my B value is going to be, hello. Looks Looks like my b value is supposed to be 3, and my m value, -4, which I need to turn into a fraction. So down 4, right 1. Okay, and this is going to be dashed. Now just focus on what you're doing. It's easy to get all mixed up by the other graph, So focus on the dashed line because we're shading below the dashed line, which I already know is going to be like, this is going to be, I can already see what my final shading is going to be. It's going to be all in here, but below the dashed line is all the way, right? And so like I just said, looks like this is where I shaded double, right? So my final graph is right there. Another example. This has got to be the last one. Oh, yeah. All right, so b equals what? 1. M equals 2. Since it's slope, might make it into a fraction. Begin with b, move with m. It's less than, so it's going to be solid or dashed. Dashed. Dashed it is. So we have a dashed line here. And we're shading what? We're going to shade above or below. It's a less than, so we shade below. And this guy has a b value of -3 and an m value of 2. This one also has an m value of 2. These have the same slopes, which means they're going to be parallel. Begin with b, though. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And this one's also dashed, isn't it? And it's greater than. Does that mean we shade above or below? It means we shade above all of this. Everywhere. Calm down, Mr. Falk. But the final answer, where we shaded double, looks like to be everywhere in between the parallel lines. And that's that, I guess. But one final side note, I guess. Just take these same two lines, right? Can you imagine, watch carefully, what if this line, okay, so I guess this guy, what if this one, what if it would have been a less than? What if this one would have been less than, and so shade, 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 and what if this one would have been greater than? So it would have been like shade, 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 oopsie daisy. So shade, 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 shade. What would have been the final answer? If there wouldn't have been any overlap, right? And if there's no overlap, guess what? Then there's no solution to the system, to the pair of inequalities, right? So you can run into like weird examples like that. I don't know if you will in this class, or probably not even on the keystones, but just saying. And how about one more weird one, right? What if this guy would have been greater than, okay? So imagine greater than this guy. And what if this one was also greater than? Yeah? What then? This one's greater than, I think then it still would have been right in here, right? Anyway, you can have weird examples, I suppose, but so again, that's 6-4, man. Basically, it's like taking 6-3 and just doing two of those in at once, like a 2-for-1 special. But you just got to remember that you just got to make the final graph is not just putting both of them on the same plane. It's making sure to finalize like where you had double shading.